Hi, you guys. Today we are going to be talking about present value of interest. So I just want you guys to go ahead and make sure you have the formula down for the present value of a single deposit investment. And that equation is P equals B divided by 1 plus R over N. Close those parentheses to the NT power. Those variables still stand for the same thing. So P is the principal, B is the ending balance. We have R is our interest rate, N is the number of times that it was compounded yearly, and then T is the number of years. So we have an example. The Moultrie family knows that in 6 years, their daughter Angel will be attending a university. She will need to about $20,000 just for the first year of tuition. So, how much should the callers deposit into an account that yields 5% interest compounded annually in order to have that amount? So, the reason why I know I'm going to be using that single deposit present value deposit is because we want to know how much money we're going to put in the account now so that when Angel decides to go to college in 6 years, then she will have more money to go to college. So the reason why I know it's a single deposit is because I'm only putting it in that one time and I'm just going to watch it grow. I'm not making multiple deposits. So what we're going to do, we're going to go ahead and identify each of those values. So if we go ahead and use our formula here, we're going to identify each of those known variables. So we have our P, which is our present value that we're going to be entering in there. That's what we're trying to figure out. We don't actually know. But the ending balance, what we want it to be, if you look back here, is the $20,000. Okay. Then our interest rate is that 5%. We need to move that percent to 2 times to the left. So it'd be 0.05%. It's getting compounded annually. So it's only one time for our N. And then that's going to be a total of 6 years. So that T is going to be 6 for our years. And then we can actually go ahead and write those down on there. So the P was our question mark that we're trying to figure out. And then we have our actual step 2, which is since we figured all those out, we're going to now plug it into our formula. So when we have it in our formula, you see that it looks like this. So just double check that all your locations are correct on where it is. And then our step 3, now we're actually going to put it in our calculator before we're going to simplify using PEMDAS. So our first thing that we're going to do, we're going to see that we are able to simplify a lot of it. So we have our 20,000 now divided by 1 plus 0.05, making that a decimal, that fraction a decimal. And then we're actually able to do 6 times 1, which is just 6. We can still simplify that PEMDAS again. So now we are doing that multiplication or the addition inside the parentheses, 1 plus 0.05, we get 1.05. And then it's going to be exponents, which is 1.05 to the 6th power. Hit enter, and then you're going to do 20,000 divided by whatever value you got for that 1.05 to the 6th power. It should be approximately $14,924.31. So basically, you have to put $14,924, or you can say approximately $15,000 into the account right now. And then in 6 years, it will finally eventually get you that $5,000 to help pay for the rest of college. So you're putting a lot of money in right now because it's just such a low percentage interest rate. Okay, let's go ahead and try this example number 2. So Abel wants to install a movie theater in his home in 3 years. He estimates that the total cost is going to be $15,000. So how much money should he deposit monthly, into his account that pays 4% interest rate compounded monthly? It's also monthly in order to have enough money. So now this is a periodic deposit because he's going to be putting money in his account every single month. And it's still going to be how much is it present value because he's the one putting in the money. So we're going to go ahead and actually use our equation for our present value of periodic investments. So that's this big one. We're going to go ahead and identify our variables again. The P, the present value, we're trying to figure out how much he needs to be depositing monthly in order to get his $15,000. So B, the ending balance of $15,000 is going to be our B value. We're identifying our variables for step 1 right now. Then we're going to multiply that by the interest rate, which was 4%. Make that percent sign 2 times to the left, making it 0.04. Dividing by n the number of times it's being compounded, which is monthly, so that means it's going to be 12. So we have 0.04 divided by 12. Right, and again, we're still just identifying our variables. Then we're going to divide that by the 1 plus our interest rate was 0.04, n was 12. We're going to bring it to the exponent of 12, and then we're also going to do the time that it is, which is 3 years. So he has 3 years to save this money. So T is 3, and we're going to subtract that by 1. Once we have all of our variables actually set up, we're going to go ahead and plug it into this formula. So it should look like this. If you guys don't have it, go slow. Check to see what you did. Make sure you have them all plugged in correctly. And then we're going to go ahead and simplify things. So you make sure you are going through, you are dividing that 0.04 divided by 12 first, and then multiplying it, hitting enter, getting a number. And then down below too. If you guys have fancy calculators, you can actually enter it in your calculator like almost exactly like this. And you would get your answer of $393. So he has to only put $393 in his account monthly for the next 3 years to get his $15,000 to buy his movie theater. So that is our complete sentence for that as well. So Bell must deposit $393 every month to reach his $15,000 in 3 years. All right, so I want you guys to go ahead and try this problem on your own. Lucia just graduated from college. She wants $100,000 in her savings account after 10 years to buy a house. So how much must she deposit in that account now at a 3.8% interest rate compounded daily in order to meet that goal? So I want you guys to go ahead and try this. Tell me what, or show me what, make sure you have what formula you're using, actually the actual formula first before you plug anything in. You should be identifying your variables, then plugging in your formula. Hopefully you guys can tell the difference between a single deposit versus a periodic deposit and know how to do that. And I'll be checking for this when I check your notes. The second example I want you to do is also on here. I want you guys, Anna Maria wants to save a total of $200,000 in 12 years to buy her dream car and a boat. She is willing to set up her monthly paychecks to get directly deposited into her account. With a 4.5% APR, annual percentage rate, compounded monthly, how much does she need to take out of each check in order to reach this goal? Again, you guys are going to try and figure out what formula you need to use for this one, and I will be checking your work to see if you got the answer correct in your actual notes. Okay, so once you guys have done those 2 problems on your guided notes, you're going to go ahead to your homework, which is page 165, numbers 2 through 9. You guys are a little hint for you guys. Pay close attention to the wording of each problem because it is going to be changing back and forth between the single deposit and periodic deposit. So make sure if you're putting money in only in one time, that's the single deposit. And if you're watching it grow, then that's going to be your present value that you're going to be putting money in now, watch it grow. Or is in depositing money periodically. So you're putting money in monthly, weekly, taking out of your paychecks, thing like that. And that's going to be your periodic deposits. The last thing on your guys' guided notes, I want to make sure at the end here, make sure that you guys can ask me a question if you guys are confused about something, or you can even make a comment on something that you were like, whoa, that's awesome, or I'm just kind of still curious about this, or just kind of something about the lesson. So you guys need to do that in order to get the full credit on this set of guided notes for me. So again, go ahead and enter a question or comment at the end of the guided notes, and I will see you guys next time. Thanks.